think my screen is sharing, so I'll go ahead and get started. Um, over the past couple months, I've been trying to look or analyze the idea of development, and some of the shortcomings of the world of development, the development industry, looking at it from different perspectives. We've talked about education and development, health and development, et cetera, et cetera. And today, unfortunately, we're going to have a kind of a bad news type of class. I wanted to look at climate change and think about, kind of present really, I think, some of the facts that are on the ground, some of the possibilities related to global climate change that are not being considered. I think at this stage in the game, everybody knows what global climate change is. Everybody knows the effects of greenhouse gas emissions. This has been widely talked about, discussed. Almost every government in every nation around the planet is signing up for all these agreements about reducing carbon emissions, about meeting certain sustainability targets. However, despite all of this information, all of this wealth of knowledge about what's causing global climate change, there is also I would say, very worrisome underreporting, both by the media, by governments, by institutions, about really what is occurring, right? And I think that that's something I want to talk about is like, it's important to understand that if things do not change, there is a very real possibility that that's the worst scenarios of global climate change could grow far beyond our control. I'm not a climate scientist at all, but I am very interested in the subject. I have three young children. And when we talk about today, they talk about, uh, what is the level of warming that we might achieve by the year 2100. And so I don't expect to be alive myself by the year 2100, but I do have children who will be alive, I hope, at that time. And so now, because of the approaching calamity status, I guess you could say, of global climate change, I think it's becoming ever more real. Obviously, we're seeing the effects of global climate change. We're passing thresholds, but these worst case scenarios that kind of seem dystopic in a sense are issues that our children are going to face. And that makes it something that has driven kind of my own research into this. And then also trying to create some sort of connections to the area of work where I am involved, which is the development industry. So the class outline is I want to take a quick look at the climate change history. We're going to talk a little bit about the shift from this extraordinarily stable climate moment, which was called the Holocene, a geological epoch, to what many geologists are saying we've now left the Holocene, we moved into the Anthropocene, which is, this new geological age that is created by the direct impacts of humanity upon the world in which we live. Then real quick, I want to take a quick look at the evidence of climate change. I think most of us know that, yeah, it's getting hotter, storms are getting stronger, but NASA just released some new data about what exactly is occurring, which I think is important to analyze. And then at the end, I want to kind of take a a negative turn or a depressing look at some of the really bad news that, like I said, many climate scientists are starting to come out and saying, look, our models about what could happen with global climate change are showing that these potential worst case scenarios are becoming increasingly likely. And that's something that's not being reported by the media. It's not something that is being taken into consideration as we, as a global community, try to devise these strategies for reducing our emissions, moving towards a more sustainable future. And I think it's extremely important that we take a look at some of these worst case scenarios, not necessarily as doom mongering and saying that this is the end of the world, collapse is imminent, but saying this is a very real reality that we have to understand, that we have to take account, and that should guide our own individual action, our own behavior, the way that our community adapts, and also, of course, national and international policy. And then lastly, I'm going to try and make a connection to the world of development, how development projects, those of us who work in the development industry, can try to respond faithfully to how development projects can increase resiliency given the increasing likelihood of these worst case scenarios. So let's start with a little bit of history. Climate change isn't a new idea. We've known about climate change for over 100 years, almost 125 years now. It was back in 1896. There was a Swedish scientist named Svante Arrhenius, I think that's how you say his name, that started predicting. He published a paper in 1896 in an academic journal saying that changes in atmospheric carbon dioxide levels could substantially alter the surface temperature of the world through the greenhouse gas effect. So we already knew about this possibility. You know, this was at the beginnings of the industrial age. We were burning ever greater amounts of coal. The oil era was about to get started, and already people were starting to see, look, this is an enormous amount of carbon, which is the essence of life. You know, we're essentially burning, I like this term, ancient sunlight, right? Every ounce of coal and oil and natural gas that we use is the process of the earth creating carbon, which is the essence of life, through plants and animals that has then decomposed and been safely deposited underground. And people understood that if we take this stuff out of the ground where it has been sequestered and stabilized and start to burn it, there are probably going to be some pretty serious consequences. We've had 125 years of warning. And I think it's very important to understand that. Back in 1938, about 80 years ago, 90 years ago, Guy Callender, a UK scientist, connected carbon dioxide increases in Earth's atmosphere to global warming. Already back in 1938, we were having data, receiving data that showed that there was a warming trend in the Earth's atmosphere. And it's, I mean, that for me, that's depressing. You know, it's not something that we just happened upon, 20 years ago, 30 years ago. We've had over a century to understand this and hopefully try to interact that through policy, through changes in our energy policy, and we haven't done that. On a longer scale, if we go longer back, if we look back on more of a civilizational nature, on a geological epoch, Earth's climate always changes, right? It's, in the last 800,000 years, there have been 8 cycles of ice ages and warmer periods. The Earth by itself kind of regulates climate, right? So you have an ice age that gives into a warming period, and then as it warms, it rains harder, and the rain hits the bedrock, and the bedrock demineralizes and goes into the ocean floor, and the ocean, all of those minerals sink into the ocean, to the bottom of the ocean, and this captures carbon. And it's a cycle of warming and heating. And if you look at this graph, it goes back about 12,000 years ago. You see the fluctuations going above and below, that push us from ice ages back into warmer climates, right? So a lot of people say, well, we shouldn't worry then. This is just something cyclical. The world is always kind of changing, going higher and lower. But again, if you look at this graph, for the past 10,000 years, which is roughly the time of human history, ever since the beginning of the agricultural revolution, the Neolithic revolution, when we went from mostly hunter and gatherer society to more settled communities, the rising of community and states and governments. Over that past 10,000 years, our climate hasn't changed much. And you can look at this and we don't see these massive peaks of hot climates and then ice ages, right? So the last ice age ended about 11,700 years ago, marking the beginning of the modern climate era and the beginning of human civilization. Most of these climate changes are attributed to very small variation in Earth's orbit that changes the amount of solar energy our planet receives. While Earth's climate has changed throughout its history, the current warming is happening at a rate that has not been seen in the last 10,000 years. I'm going to move. I don't know if y'all can see this, but if you see this graph, we have this enormous amount of stability. And then here at the end, we have this hockey stick graph, which is something that really defines our age. In the last 100 years, in the last 50 years, all of a sudden, everything is peaking, whether it be statistics, demographic statistics on population, resource use, and obviously climate change is one of those as well. So this peaking is something that we haven't seen as a species for the last 10,000 years. The Holocene is this moment of the past 12,000 years, roughly, of unheralded climate stability. The Holocene is a brief flash of time compared to previous geological epochs and is in reality just an interglacial period of the current ice age. All of recorded human history has occurred entirely within this period, right? So when we read history books, everything that has happened in the past 10,000 years has depended on this incredibly stable climate regime that has benefited humanity. However, since then, the average temperature of the planet has fluctuated by no more than 1 degree Celsius. Put another way, the past 12,000 years of human history, corresponding with the rise of agriculture, settled community, has occurred within this framework of unheralded climate stability. What's happening now? Well, what's happening now is we see this increase, this peak of carbon levels in the atmosphere, carbon dioxide levels in the atmosphere, and the corresponding, growth in temperature. So how do we know this? Ice cores. All around the world, we have the, extremely thick layers of ice, and scientists can go and pull out these layers of ice, and it's essentially a window into the past. We can see exactly how much carbon dioxide was in the atmosphere 12,000 years ago, 50,000 years ago, 100,000, 800,000 years ago. And by doing this, we can see through these ice cores that are drawn from Greenland, through mountain glaciers, we show that the Earth's climate responds to changes in greenhouse gas levels. Ancient evidence can also be found in tree rings, ocean sediments, coral reefs, and layers of sedimentary rocks. This ancient or paleoclimate evidence reveals that current warming, what's happening now in the last 100 years roughly, is occurring roughly 10 times faster than the average rate of warming after an ice age. So if we go back 100,000 years ago, and this cycle of going from ice ages to slightly warmer thing happens because as the Earth rotates around the sun, we receive a little bit less solar energy. But this warming was generally slow. It was something that happened because of the Earth's trajectory through the universe. But now we're seeing this warming occurring 10 times faster than the average rate of warming after an ice age. Carbon dioxide levels, which we know today are coming from human activities, especially from the burning of fossil fuels, is increasing about 250 times faster than it did from natural sources after the last ice age. There's now abundant and clear evidence that this warming is not cyclical. It's not something that comes, because we're leaving an ice age and going back into something hotter. This is something different, and this is what's known as the Anthropocene. This is a new geological epoch where the actions of the collective actions of humanity are changing our climate. It's also important to know, from a civilizational standpoint, the Holocene is the only state, the only geological era in which we are sure that we know for certainty that humanity can thrive with anything like the almost 8 billion humans being supported today. We have now left the Holocene, and we are in the transition towards the Anthropocene. This new geological epoch was named to acknowledge human influence on the state of the planet, right? And past, in the past, geological epochs lasted millions of years, right? And we went and they were, caused by, everything from, asteroid hitting Earth, drastically changing the climate, things that are obviously beyond, they're kind of catastrophic in nature. But it's important to mention that the Holocene didn't last a million years. It's something that lasted very shortly, and we're quickly moving away from that. Okay, so we know that something is happening. Our climate is changing, and there's abundant evidence that this is due to something that we are doing. What is the evidence of global climate change today? This is all of the next 5 or 6 slides are from a recent report that was released by NASA. And these are things that I think everybody knows, so I'm going to go through these pretty quickly. But yeah, global temperature is rising. We know this. The planet's average surface temperature has already risen about 1 degree Celsius since the late 19th century, a change driven largely by increased carbon dioxide emissions into the atmosphere. Most of the warming occurred during the past 40 years, so this is something that is increasing, right? With the 7 most recent years being the warmest. The years 2016 and 2020 are tied for the warmest year on record, and 2024 is expected to probably beat 2020. So it is getting hotter. Global climate change. When I was a student in elementary school, I remember we had class idea that the Earth was going to get warmer sometime in the future. It was something projected into the future. No longer. Climate change is something that is happening, and there's abundant data showing that the world is hotter than it was. Right. The ocean is getting much warmer as well. The ocean is important because it absorbs the vast amount of the majority of the heat, with the 100 meters of the ocean showing warming of about a third degree Celsius since 1969. One of the things that's interesting, I don't know if you can see this graph, but this maps the average ocean temperature. Obviously, it goes up and down throughout the year, as we move into winter and then back into summer. But there's generally this correlation. But if you look here, 2023 is the yellow graph, showing that all of a sudden in the last year or two, the warmth of the ocean, the temperature of the ocean is increasing. And through 2024, we're only a little bit over halfway through the year, we can see that we're already breaking this. The ocean is getting extremely hot, much faster, even faster than what that we see and warming above the ocean surface, right? One of the things that's interesting here in Central America, where I live, we always have hurricanes. Hurricanes are a part of the natural cycle. But usually hurricanes obey to the warming temperatures of the Atlantic Ocean, right? And the Caribbean Sea where we live. And usually we don't get big hurricanes until later in the year. So around September, October, after several months of warmer temperatures during the summer, right? This year we had Hurricane Beryl. Hurricane Beryl was at the end of May. So, we're just now leaving the cold temperatures of winter, and the ocean should be significantly cooler around that time of the year, but it's not. It's getting hotter, so we're seeing these extreme weather events happening earlier and earlier in the hurricane season. Another evidence of global climate change is that ice sheets are shrinking. Greenland and Antarctica ice sheets have decreased in mass. Data from NASA shows that Greenland lost an average of 279 billion tons of ice per year between 1993 and 2019, while Antarctica is losing about 148 billion tons of ice per year. There's all these scenarios where if climate change continues, these ice sheets are going to continue to melt. There's these ice shelves throughout the Arctic and Antarctic that are in very real danger of breaking off. And as we see, if this does happen, what we can expect is an enormous rise in sea level. That's important, obviously, because at least a third of humanity lives in areas near the coast, near the oceans, seas, where rising sea levels are going to make it impossible to live there. Global sea level has already risen about 8 inches or 20 centimeters in the last century. The rate of this sea level rise in the last 2 decades, however, is nearly double that of the last century, and it's accelerating every year. This is a picture of Italy, one of the most kind of well-known land masses, the famous boot. And what it shows is that the boot is getting smaller, right? It's not a woman's boot anymore, it's a child's boot. And as sea level continues to rise, all of these coastal areas around the world are going to become inhabitable. And you already see this in places like in Miami in the United States, in other wealthier countries. Local governments and national governments are investing billions of dollars in building seawalls to try and stop this, right? To try and say, look, there's billions of people living here. There's an enormous amount of wealth involved in coastal properties and all of this. And how can we try and stop this? Obviously, countries in the developing world where there's not that amount of money, people are going to be forced away from these coastal areas, increasing what's known as kind of the climate refugee kind of issue. Another is extreme weather events are increasing in frequency. The number of record high temperature events in the United States and Europe is increasing. I think recently in India, they broke a record earlier this summer with a high temperature of something like 54 degrees Celsius. These are temperatures that the human body is incapable of withstanding, especially when we talk about the combination of high humidity, which is also an issue related to global climate change, and extreme temperatures. There's something known as a global wet bulb temperature, which is when you combine a temperature above 39 degrees Celsius with a certain degree of humidity, which is somewhere around 80%. When that happens, the human body biophysically cannot operate. And there's a lot of theories that if we continue this path, there's going to be areas around the world where these wet bulb temperatures will become common and could lead to massive die-offs, massive amounts of death of people who are not able to, have an air-conditioned space or whatever it might be. Obviously, other extreme weather events are, stronger hurricanes, like I mentioned earlier, longer droughts that lead to wildfires, et cetera, et cetera. Another evidence of global climate change is ocean acidification. We talk a lot about the importance of trees and forests and helping to sequester carbon dioxide, but what many people don't know is that the oceans are the real sink for the excess amount of carbon dioxide. This is kind of how our natural system works. It's how the Earth has always regulated its climate through time, is that the excess amount of carbon dioxide in the atmosphere is absorbed by the ocean. Plankton play an important role in this. However, since the beginning of the Industrial Revolution, the acidity of surface ocean waters has increased by about 30%. This increase is due to humans emitting more carbon dioxide into the atmosphere. So what happens is carbon dioxide is in the atmosphere, it gets absorbed by the ocean, and it gets turned into what is known as carbonic acid. And that what happens when we get this increased ocean acidification is all of the issues with the die-off of coral reefs, the death of lots of different types of marine animals. There's a lot of issues about how plankton are being affected, and this in turn can reduce the capacity of the ocean to continue to absorb more carbon dioxide. So it's kind of this fear that if we continue to heat the oceans, and the oceans continue to become more acidic, they could have a drastically reduced impact in absorbing the excess amount of carbon dioxide that we're putting into the earth. So all of these evidences of global climate change we've mentioned are fairly well known, fairly well established. It's pretty bad news, right? Nobody likes to hear bad news, but these are statistics that are accepted by 99% of climate scientists. What many climate scientists and governments and institutions and the global media do not report is what I'm going to say next, the really bad news, right? We've already talked about the bad news. Now we're going to make it even worse news. And I think it's important to say this because these are not what I'm going to report right now is not the work of some extremist doom monger or somebody who is hoping that the world collapses. The really bad news, these worst case scenarios, are being put forth by the IPCC, the International Panel on Climate Change, by leading climate scientists. This is stuff that has been known. Like, there's a lot of unknowns with global climate change. We know that the world is getting hotter. We know that the ocean is getting more acidic. We know that extreme weather events are becoming stronger and more frequent. But we don't know exactly how this is going to evolve, right? There's a lot of, I guess, leeway in predictions. And one of the ways that climate scientists kind of think about what might happen in the future is through what they call different scenarios, right? Different concentration pathways of how much carbon dioxide might be emitted into the atmosphere. So this is from the IPCC, the first quote, the best case scenario, right? This is the best case scenario. If all of the 2030 national determined contributions towards the reduction of carbon emissions are fully implemented, that is, if all of the developed countries around the world meet their carbon zero pledges, and if all of the developing world begin a pathway towards development that isn't carbon intensive, that isn't dependent on burning more fossil fuels, we're still expecting a warming of 2.4 degrees Celsius by the year 2100. So that's important to say. A couple of years ago, back when we in the Copenhagen Accords, in the Paris Accords, they still discussed about maintaining global climate change to under 1.5 degrees Celsius. We've thrown that beyond. We know that that's impossible. Now everybody is talking, we need to reduce our carbon emissions to try and keep global climate change under 2 degrees Celsius. But the leading climate scientist, the IPCC, says that even if all of these ambitious carbon reduction targets are met, we're still going to be seeing at least a 2.4 degrees Celsius increase by 2100. And it's important to mention that these 2030 carbon reduction promises that have no teeth, right? If a country decides to burn more carbon dioxide, burn more coal, burn more fossil fuels, there is no penalty, there's no fine or anything like that. There's no trade wars going on. It's completely voluntary at this point. And we're not meeting that. We're going to look at some of those statistics a little bit later. But that's the best case scenario. There's also worst case scenarios. So these are called the RCP. These are the different climate modeling scenarios put forth by the IPCC and other climate scientists. This right here, RCP 2.6, is the best case scenario. But RCP 8.5 is the worst case scenario, and it's something that many climate scientists say is an increasing likelihood. At the opposite end of the spectrum, this would entail more than 4 degrees Celsius and warming above pre-industrial levels, almost a doubling in expected warming. This is due to rising emissions. Hundreds of millions of people will be forced to migrate, and there will be an enormous increase in forested areas prone to the types of fires that have been raging this summer. This was, again, the words of the IPCC. And even this RCP 8.5 isn't the worst isn't the worst case scenario, right? The worst case scenario is that because of the inability to really predict what might happen, there are other scenarios that are even worse than this famous RC than the worst case scenario. There are scenarios that are worse than the worst. And that's because there are feedback loops in the carbon cycle and what's known as potential tipping points that could generate higher greenhouse gas concentrations that are often missing from models, right? So all of the models that the ICPP puts forward are kind of based on this idea that we're going to limit our greenhouse gas emissions, especially from carbon dioxide, from burning fossil fuels, by changing our livestock, the way we raise livestock to reduce methane emissions, by trying to reduce the anthropogenic or the human sourced greenhouse gas emissions. However, there are these tipping points that might be beyond our control. So, for example, if we continue to release greenhouse gas emissions, the world gets hotter. The Arctic, which is warming much warmer, the northern part of our world is warming much faster. That the Arctic permafrost might begin to thaw, and that would release an enormous amount of methane and carbon dioxide. And that's not something to do with human, that's not, from drilling or from land development in the Arctic. That's just because of the warming that we've already had could potentially release this permafrost. Carbon loss due to intense droughts and fires in the Amazon. The Amazon rainforest is one of the largest carbon sinks in the terrestrial world, similar to the ocean. But because of increasing temperatures, lots of, many areas of the Amazon rainforest are reducing the rainfall. It's getting hotter. And what's happening is the rainforest is burning. There's an enormous amount of wildfires every year during the dry season in the Amazon. And a lot of people talk about the Amazon in the coming years could shift from becoming an enormous carbon sink to becoming a carbon emitter, right? Another one is the apparent slowing of the dampening feedback, such as the natural carbon sink capacity. Soils are an enormous sink of excess carbon dioxide, right? But because of our industrial agricultural model, many of the world's soils are degraded, and this leads to more carbon emissions. And then the worst case scenario is this idea of the tipping cascade, in which multiple tipping elements interact in such a way that the tipping of one threshold increases the likelihood of another. So let's say that the Amazon rainforest all of a sudden turns into a savanna. It's no longer rainforest. This would lead to an enormous amount of carbon emissions through the burning, through wildfires, through the die-off of enormous amounts of tropical rainforest. This excess amount of carbon dioxide that goes in the atmosphere could push us past the tipping point where we lose an enormous amounts of Arctic Sea ice, where the Greenland ice sheet collapses, where the permafrost from the Arctic starts to release all of this methane, et cetera, et cetera, et cetera, right? So all of these tipping points, we don't know where they are, right? There's not something to say we have to keep the atmospheric carbon at under 450 parts per million. Nobody knows when these tipping points could occur, but they are likely. One of the really kind of scary things about this is that if we meet all of these tipping points, if something happens, then climate change is beyond our control. Even if we were to reduce our carbon emissions to absolutely zero, even if every person in the world stopped consuming oil and coal, if we all had solar panels, if everybody became a vegan and there were no more livestock related emissions, even then there's nothing we could do because we've passed these tipping points and the earth itself starts to heat up. This is what's known as a hothouse earth state. And like I said, nobody really knows what is the level at which this could occur. In a hothouse Earth scenario, human greenhouse gas emissions activate mechanisms in the Earth's climate that eventually push the global climate over a threshold into continued self-perpetuating warming. independent of human emissions. Recent simulations suggest that one of these tipping points could be that stratocumulus cloud decks, which means these really, really high clouds that are high in our atmosphere might abruptly be lost when CO2 concentrations reach a certain level that could occur by the end of the century. This, if we were to lose these high layer clouds high up in our atmosphere, this would lead to an additional 8 degrees Celsius of global warming. So obviously we're talking, we want to try and keep global warming below 2 degrees Celsius, right? But if we hit these tipping points, we're not talking about 2, or even the worst case scenario, the 4 degrees Celsius. We're looking at 8, 15, 20 degrees Celsius. A lot of climate scientists have coined this term, the Venusification of Earth, moving our world into a place where life itself is not sustainable. These possibilities, all these possibilities about tipping points and positive feedback loops and hothouse Earth states, none of these possibilities are taken into consideration by climate scientists, by the IPCC, by policymakers. And recently, lots of leading climate scientists have come out and saying we need to be more careful. We need to speak clearly about these risks because we don't know where these tipping points might be. And it's important to take this into our modeling, into our policy action, et cetera. But up until now, we just assume that none of these tipping points are going to occur and that the best way to reduce climate change is by simply reducing our carbon emissions. Like we said, even in that sense, we're not being successful. We're in a moment historically of what's known as the carbon pulse. This one-time massive consumption of fossil hydrocarbons at a pace millions of times faster than they were created. It took hundreds of millions of years for coal and oil and natural gas to accumulate in the Earth's crust underneath our feet, right? But the carbon pulse, where we figured out that we could use that this was this incredibly rich and energy dense source of energy that we could use. And in the last 200 years, we have extracted enormous amounts of carbon and released it as carbon dioxide, millions of times faster than they were created. The current carbon pulse is occurring at an unprecedented geological speed, and by the end of the century may surpass thresholds that triggered previous mass extinctions. Never before have we released so much carbon dioxide in the air. And a recent review found that the world's appetite for gas remained steady in 2024, while consumption of coal climbed by 1.6% and oil demand rose by 2% to reach 100 million barrels of oil a day for the first time. So despite all of the growth in solar energy, solar panels, renewable energy, despite all the growth, all of the pledges by nations around the world, all of these UN climate summits, all of these great intentions have led to nothing. Yes, there has been an increase in solar energy and renewable energy. That's important, but it's also important to say that despite that, there has been no reduction in the overall use of of fossil fuels around the world. We continue to use more natural gas, crude oil, coal every year. So the problem isn't that we're doing well by creating alternative sources of energy, but this has led to even more demand for energy, right? So it's this whole issue we talked about in the past class of what's known as Jevons paradox, that increases in efficiency do not necessarily lead to reductions in overall use. Right? We found ways to create more environmentally friendly and efficient renewable energy sources, but we're not replacing fossil fuel based energy with renewables. We're just using more of both. This is a problem. We need to make an energy transition. But one way to look at this is that for every new megawatt or gigawatt of solar or hydropower or geothermal or whatever type of renewable energy, that needs to replace that same gigawatt of energy that comes from coal, oil, gas, et cetera. And that's not happening. Here's the worst news, right? When we talk about tipping points, many climate scientists don't know when we might hit that, but there is recent evidence that we might already be there. So we talked about the Amazon rainforest becoming a source rather than a sink of carbon dioxide. In 2020, we had, for the first time ever, a global shutdown, right? The economy stopped. And in 2020, there was a dip in carbon emissions because nobody was driving to work. Everybody was stuck in their home. And so there's one of the few times throughout recent history where we did see a drop in carbon emissions, right? People weren't burning as much fossil fuels in 2020. However, in that same year, we saw carbon emissions come down by 7%. And yet, the atmospheric carbon concentrations continue to increase. If we follow these carbon models, if we reduce the amount of carbon dioxide that we're burning, we should see a reduction in the amount of carbon dioxide in the atmosphere. But we didn't see that. What we saw was that carbon concentrations continue to increase throughout 2020. This may very well indicate that there are already some self-reinforcing feedbacks already underway. Specialists working on these Earth system feedbacks have published analysis that 9 of the 15 major feedbacks may have already begun, right? The Amazon rainforest may very well be turning into a sink, where they suck carbon dioxide from the air, into a source where trees that are burning or rotting pump carbon dioxide into the atmosphere. The loss of ice, the thawing of the Arctic, all of these may have already begun, because back in 2020, when carbon emissions dropped, we should have seen a drop in carbon atmospheric concentration, and we didn't. And that's extremely worrying. That's something that we need to think about, that we need to worry about, because that might show that these tipping points are a lot closer than what we think. All right, so to end, that's the bad news. How does this connect to the world of international development? And I think it's important to say that even in the best case scenarios, right? If we were able to limit global climate change to 2 degrees Celsius, there's going to be an enormous amount of effects on small scale subsistence agriculture. There's already going to be certain levels of raising sea levels. We've already seen in many places, in many of the low-lying islands in the Pacific Ocean, there's already been a massive migration of people out of these islands because the seawater is creeping up and covering these islands. But that's the best case scenario, right? What happens if we're not able to limit climate change to 2 degrees? What happens if we follow the climate model known as RCP 8.5? What happens even if we reach some of these tipping points and we start to transition to a hothouse Earth? Well, obviously, growing food is going to become a lot harder. There's all these very worrisome statistics, not only about topsoil loss, but about how hotter temperatures may very well make agriculture impossible in many parts of the world. Heat waves, these tendencies like we saw in India earlier this year, where we see these heat waves of 50 plus degrees Celsius. And many people have started talking about certain parts of the world are going to become unlivable, right? So not only are people going to be forced to migrate away from the coastal areas, the low-lying coastal areas, but there will also be many areas around the tropics where it's simply too hot to live. This obviously will lead to an enormous amount of migration. And that's not, something that's coming, that's something happening. I live about 30 kilometers away from one of the main migrant routes. And about a couple months ago, me and my family passed through the border between Honduras and Guatemala. And you always see migrant caravans, right? That's something we've seen for several years. But in the past, it was mostly people from El Salvador, from Guatemala, from Honduras going north, mostly those 3 countries. If you go to these migrant kind of pathways now, it's enormous. The amount of people has drastically increased, and you're no longer seeing just Central Americans. You see people from China, from Southeast Asia, from all sorts of different African countries, from South America. There's a mass movement of people around the world, and much of this movement is due to the fluctuations that we're already experiencing, in our climate. Obviously, the warmer that it gets, there's much more likelihood of pandemics and zoonotic diseases arising. Kind of COVID-19 might have been just the tip of the iceberg in that sense. All of this could lead to resource shortages, geopolitical tension, wars as we move to a multipolar world where different nations are fighting over access to resources in a world that's stressed by global climate change, financial overshoot, global supply chain complexity, et cetera, et cetera, et cetera. So when we talk about, all right, we have a 3-year fund to write a development project. What are some of the vulnerabilities? What are some of the issues we need to respond to? Well, the world of development needs to think about all of these things, because they're going to become more and more serious, increasingly likely in future years. Unfortunately, I think this is my own perspective. This isn't from the IPCC or anybody else, but this is my own critique of the world of development. is that most development projects in the world, most development organizations contribute to the westernization of the communities where they work, essentially hastening the loss of semi-resilient livelihoods in the introduction of formerly place-based peoples into the increasingly vulnerable globalized world that is teetering on the edge of climate catastrophe. I think I've made it fairly clear in many of my classes that I'm not very convinced that this globalized economic supply chain that all of us depend upon is going to continue. I think that we need to transition towards more stronger local economies, return to a sense of local agriculture where we're able to, where we don't have to depend on food that's, you know, produced in one area of the world, shipped massive distances. The same for our energy systems, the same for where we get our water for our waste disposal systems. I believe in localization, and I think that development projects, if they're going to respond to all of these vulnerabilities that we're facing, we need to try and find ways to localize. But what we're doing, what most development projects do, maybe subconsciously, maybe not, is ruin place-based lifestyles, which is, you know, forcing people into urban areas, trying to have people adopt these faulty ideals of growth, of economic development. And we've talked a lot about in the past classes about the need for degrowth in certain parts of the world, but also that areas like sub-Saharan Africa, like many parts of Latin America, not to follow this failed development model. You know, by introducing people into this model of development that is increasingly vulnerable to climate change, all we're doing is putting them, I think, on the wrong path. And I think that this is one of the major faults of the development industry, is that we ruin place-based lifestyles that I think could have a much more possibility to respond correctly to some of the vulnerabilities of global climate change. There's an author I really liked called Jem Bendell, and he talks about, you know, what can we, you know, how can we really create an adaptive response as a species, as a human species? How can we adaptively respond to some of these potential extreme climate scenarios? And you say, if, you know, we don't know if they're going to happen. Maybe this is all just doom mongering, and things are going to happen. Maybe we'll get our act together, and by 2030 we'll phase out fossil fuels, but probably not, right? So what happens? How do we adapt as a species, right? Understanding ourselves biologically, culturally, how can we respond to this? And he has his what he calls his 4 R's: resilience, reconciliation, relinquishment, and restoration. Right? Resilience. How do we keep what we really want to keep, what we most value? Right? So how can we maintain the essentials in the phase of climate and societal breakdown? Development organizations need to think about that, right? As it gets hotter, as droughts are longer, as extreme weather gets stronger, how can we ensure that local communities are able to keep the most essential things, that they can grow their own food, that they can source their own water, that their soil maintains fertility? These essentials that we need to keep in place should be the essence, the foundation of development projects, I think. Reconciliation. With what and with whom shall we make peace as we face these issues? How can we maintain civility in a moment of coming mass migration and resource shortage? This is kind of a geopolitical issue, right? Unfortunately, if we look at the past, our past political movements, you know, when there are resource shortages, this leads to more wars. Can we avoid that? How can we try and create a sense of reconciliation, a sense of civility, of brother and sisterhood, as we face a lot of very, very serious challenges? I think that's a political issue that needs to be taken up, right? Relinquishment. What do we need to let go of in order to not make matters worse, right? How can we hurry the process of letting go of these unsustainable lives and livelihoods, of believing falsely that we're going to continue to grow our economy forever into the future, of believing that we're going to continue to have this global economic model where the food that we eat and the energy that we use in our homes comes from an enormous distances. How can we let go of that and try and strengthen a more localized response, maintaining some of the goodness of modernity? Nobody's saying that we need to go back to how life was 300, 400 years ago. How can we this goes back to resilience. How can we maintain the important things while letting go of the things that aren't that important, right? And lastly, restoration. What work can be done to hopefully trigger unknown feedback loops that could bring us back to a certain level of equilibrium, right? We know how to store carbon in forests. We know how to store carbon through regenerative agricultural practices. We know how to how we can try and reduce temperatures, right? So a lot of things, it's not that we just stop burning fossil fuels, but that we adopt a more regenerative lifestyle that hopefully helps the world kind of reverse this trajectory that we're facing. So yeah, resilience, reconciliation, relinquishment, restoration. How can development projects really kind of respond, following this framework of the 4 Rs? So here's a final question, and then I'll end. So we have some time for questions and feedback. How might the world of international development design projects and interventions that respond truthfully and sincerely to the potential for climate catastrophe, for all of these worst case scenarios we've looked at, in seeking to create as much resiliency, relinquishment, reconciliation, and restoration as possible in the communities where they work?